Hello friends, today's topic is transformer, which is very active role play in deep learning and machine learning. It is very important topic. Today's today's subject is related in AI and deep learning. A transformer is deep learning architecture designed to process sequence by using attention mechanism rather than recurrence and convolution. Convolution, what is convolution and recurrence? What happen in the convolution and recurrence are distinct mathematical and computational techniques used to process data specifically to capture pattern over space or time. In Transformer, introduced in 2017, it became the foundation of modern artificial intelligence system, enabling breakthrough in language model, image generation, speech processing, scientific research, and many other domain. This is the diagram of transformer. What are transformer? Network architecture for NLP and vision, computer vision. Introduced in 2017, attention is all you need. Process whole sentence in parallel. Complete sentence in parallel. First, what is the diagram? Block diagram. Input sequence, embedding, encoded layer, decoded layer, multi-head attention, feed forward, both are used in multi-head attention forward output sequence in both sides, decoding or encoding. Core idea. What is behind the core idea of the transformer? The key innovation is self-attention mechanism that allow a model to weigh the importance of different parts of an input sequence when processing information. Instead of reading tokens one at a time as a traditional recurrent network to do, a transformer can examine all tokens simultaneously, run a relationship between them even when they are a part of the part in the sequence. This parallel processing capability make training significantly more efficient, helps the model capture long-range dependency that were difficult for earlier architecture. Architecture of transformer. A standard transformer consists of two major components, encode and decoder. An encoder is in deep learning is a natural network component and that compress high dimensional input data like text and image into a compact dense and numerical representation, often called a context vector or latent space, which is related with encoder. Another is a decoder. In deep learning, decoder is a neural network model that takes a compressed representation, often called context vector or latent space, and reconstruct or regenerate or generate the final output. It maps abstract features back into the useful data such as translated text, image, and audio. Although many modern systems use only one of these parts, architectures relies on several building blocks such as multi-head attention. Multi-head attention is a mechanism in transformers model that runs multi-attention operations in parallel. Instead of looking at a sentence with one pair of eyes, the model evaluates the sequence for multiple perspectives simultaneously, enabling it to capture different types of relationships. For example, syntax versus semantics, short versus long-range dependencies, which can be examined by the multi-head attention. Feed forward or neural network. In a transformer architecture, the feed forward neural networks acts as a model localized process and knowledge retrieval engine. Position after the multi-head attention mechanism in every transformer block. It dependently process each token to extract deeper abstract features and transform the contextualized data for the next layer. Residual connection. What is residual component in transformer? Residual connection or skip connection. This is two names: residual connection or skip connection. In transformers are shortcuts that add a layer's original input directly to its process output. Expressed mathematically. In mathematically expression, output is equal to x plus sub layers x. The mechanism is the backbone that enables the training of exceptional deep network. Layer normalization. Layer normalization, that is called layer norm, is crucial techniques used in the transformer model to stabilize and accelerate training. Instead of normalizing across the batch dimension like batch normalization, layer norm normalize across the feature dimension independently for each individual token and sample and position encoding. Position encoding inject information about the order or position of the token into a transformer model, because transformer process word in parallel rather than sequentially. This technique ensures the model understand the word sequence, distinguish between sentence like no it is good and it is no good, which provide information about token order. Because attention itself does not inherently understand sequence positional information is either, so the model can distinguish between different token arrangement. Why it matters? The transformers fundamentally change the trajectory of machine learning. It transformer can completely, not be completely, but 80 to 90% change the dynamics of the machine learning by the help of transformer trajectory. Its scalability allow performance to improve as model are trained with larger data set and greater computational resources with the help of transformer. This property led to the emergence of large language model LLM and foundation models capable of performing a wide range of tasks from a single architecture. A single architecture can perform number of tasks with the help of transformer. Design has largely replaced recurrent neural networks for many sequence process application, has influenced Yale beyond language including computer vision, biology, robotics, multimodal AI system. These are the which can affect the machine learning or AI with the help of transformer. Major variant. Several influence architecture built upon the transformer framework. Is a BERT. It stands for Biodirectional Encode Representation from Transformer. Encoder focused architecture for language understanding. BERT is held for language. GPT, decoder focused architecture optimized for text generation. Obviously, T5 treats many NLP natural language processing tasks as text generation problem. Vision transformer applies transformer principle to image recognition. Swing transformer efficient architecture for computer vision task. Limitation. What is the limitation of transformer? Despite its success, the transformers has notable challenges. The computational and memory cost of attention grow rapidly with sequence length and making very long context expensive. Model also requires substantial data computing resources for training, which can limit accessibility and increase environmental and financial cost. Researchers continue developing more efficient attention mechanism, sparse architecture, and alternative design to address these constraints while preserving the strength that made transformers so effective. Application of transformer. Natural language processing. What is the application of transformers? First, natural language processing or generative AI. Transformers are the driving force behind the generative AI evolution. Conversational AI. They power large language model like ChatGPT, Cloud, and Gemini to hold human-like conversation and answer quick queries with the help of transformer. Translation. They break language barrier by translating text in real time, accurately capturing idioms and context by the help of transformer. Summarization and writing. They condense long documents into bullet points, different draft emails, and generate creative writings. Computer vision. Originally built for text, transformers are now highly effective at interpreting visual data. Image recognition and segmentation. Models like vision transformers, they classify object in image and map them out of self-driving cars. Generative AI. Generative art. They translate text description into highly realistic image or videos. Healthcare and biology. Transformer can treat biological sequence like DNA or amino acid, much like human language. Genomics. They identify pattern in DNA sequence, predict the effect of mutation, and aid in personalized medicine. Drug discovery. They accelerate the invention of new drugs by predicting how proteins will be folded and interact with different compounds. Software coding. Code generation. Tools like GitHub, Copilot use transformer to understand natural language prompt and automatically write, complete, and debug software code. Audio and speech processing. to text. They parse audio signal to provide highly accurate real-time transcription and voice command recognition. This is a brief description about transformers. Transformer. What is transformer? What is the role of transformer? Our application of this. Have any question regarding transformer? Please write the question in comment box first. Then after that, subscribe the channel, share the channel, and like the channel to improve the performance in YouTube algorithm. Thank you very much.